In this video, we will be solving a titration of a weak acid with a strong base. This problem involves 5 steps, A, B, C, D, and E. So let's get started. So titration of a 75 milliliters of 0.04 molar HA, pK has a value of 6.27, Ka has a value of 5.37 times 10 to raise to negative 7 with 0.2 molar NaOH. We want to find pH of the following B through E. First, we want A, volume of NaOH needed to the equivalence point. So we'll do that first. So for the equivalence point, that would mean that the mole of H plus is equal to the mole of OH minus. So we have 75 milliliters of 0.04 molar HA. So we say 75 mils times 0.04 capital M is equal to, we have a 0.2 molar NaOH. So we say 0.2 molar times X, because we want to solve for X. We want to know the volume of NaOH needed to the equivalence point. And so X would equal 15.00 milliliters of NaOH. So this right here is the first answer. This is part A. Now we want part B, C, D, and E. For these four, we want to find the pH. So we want to know, before base is added, what is the pH? So we're just focusing on the weak acid. So we're just focusing on the HA. So we say Ka is equal to X squared divided by, we have 0.04 minus X. So Ka, the value of Ka was 5.37 times 10 raised to negative 7. So we say 5.37 times 10 raised to negative 7 is equal to X squared divided by 0.04 minus X. Now we will solve for X, and X would be our H plus value. So X is equal to, so I'll use a calculator here. I'll use the TI Nspire CX cost. I'll hit menu, I'll hit algebra, I'll hit solve. So we had 5.370 times 10 raised to negative 7, and this would equal, control division, we have X squared divided by 0.04 minus X. We will solve for X, comma X, and we would get 1.46 times 10 raised to negative 4. But let's just see, let's say we didn't have a calculator. And so this problem would be pretty difficult if we didn't have a TI Nspire CX cost. Let's just see if I ignore this minus X, and I just did this, and I hit enter. I would get almost the same answer. Now this right here, we really didn't need a calculator solve, because we could have done 5.37 times 10 raised to negative 7 times 0.04, and then we would have done a square root, and then we would have got X equal to this number. Now this answer right here is more precise, and so I will keep it. 1.46 times 10 raised to negative 4. So X is equal to 1.463 times 10 raised to negative 4 molar, and this right here is H plus, since we're dealing with a weak acid. So the pH value is going to be pH is equal to minus log parentheses 1.463 times 10 raised to negative 4 molar, and so we would get 3.84. Now this is the pH for part B. Next, we want to get part C, before the equivalence point of 5 mil. The equivalence point is 15 mil, so before the equivalence point of 5 mil is acceptable. And so we will be dealing with a buffered zone. So the volume is 5 mil, which will be in our buffered zone. So we can use Henderson-Hasselbalch equation. pH is equal to pKa plus log, the numerator will be the moles of A minus divided by the denominator, which is moles of HA. And a quick equation, so we have HA plus OH minus, we're adding a strong base. We would get A minus plus H2O. HA, we had 75 mils, and the molar was 0.04, so we would get millimoles. Next, we have OH minus, we had 5 mils, times our molarity, which was 0.2. This will also be in millimoles. So 75 times 0.04 would be 3 millimoles. 5 times 0.2 would be 1 millimole. We subtract -1, subtract -1, and then we add 1 here. And so we would get 0, 2, and then this is right here is 1. And now we will use the equation. So the pK value was 6.27. And so we will get pH is equal to pKa. So pK was 6.27 plus log A minus was 1 divided by HA was 2. So this is going to equal 6.27 plus log of 1/2. And so this right here will equal 5.97. This is the answer for part 3. So we just got before the equivalence point of 5 mil. Next, we want to know at the equivalence point. And so the equivalence point was at 15 mil. So V is equal to the equivalence point, which was 15 mils. So we will say that KB is equal to KW divided by KA. KW is always 1.0 times 10 raised to -14, and our Ka value was 5.37 times 10 raised to -7. So Ka was this right here, and so this right here will equal 1.86 times 10 raised to -8. And so we will say that 1.86 times 10 raised to -8 is equal to x squared divided by parentheses. Now we focus on the molarity of the acid. So we had 75 mils of 0.04 molar HA. So we say 0.04 times 75 mils divided by, now we divide by total volume. So initially we had 75 mils, but now we want at the equivalence point, so we're adding 15 milliliters of NaOH, so plus 15 mils, close parentheses, minus x, and now we solve for x. X will equal OH minus. And so we will use a calculator to solve. So using the TI Nspire CX cost, we would get 0.0004025, so 2.49 times 10 raised to -5. And just to see what would have happened had we not had a calculator, we could have ignored the minus x, simply hit enter, we would have gotten almost the exact same answer. Now this part right here is easy to solve without using a calculator, because this part right here times this, the answer, the square root, would have been this answer. And so we'll write that down, 2.49 times 10 raised to -5. So 2.49 times 10 raised to -5. Now we will solve for pH. So pH is equal to 14 minus log of our OH minus, which was 2.49 times 10 raised to -5. This will equal 9.40. And finally, we will do the last one. So after adding 0.3 milliliters more than the equivalence point, meaning we have 15.3 mils. After the equivalence point, it's fairly easy. So we have V is equal to 15.3 mils, 0.3 milliliters more than the equivalence point. We say OH minus is equal to the molarity of OH, which was 0.2000 times the excess, so that was 0.3 mils, divided by our total volume. Initially we had 75 plus 15.3. This will give us 6.6445 times 10 raised to -4. So we say pH is equal to 14 minus log, parentheses this, 6.6445 times 10 raised to -4. And so we will ultimately get 10.82 for our pH. So however, we didn't answer this question at the half equivalence point. We did before the equivalence point and we did the equivalence point, but what if we want to know at the half equivalence point? Now this is very easy. It's simply the pKa value. So it would be 6.27. And that's all we need to do for these problems.